Hello, welcome to the stream today. Oh, that's the wrong window. Hello, I'm just doing some talking on Discord. I'm trying to figure out what I should do. Let me put on some music while I do this. Alright. Alright. Okay, so I'm talking on Discord. I have never actually used blue noise volumes before, and that is what I'm trying to generate. I have the algorithm. I could extend it to n dimensions, so it's just going to be slower than 2D. But that's pretty cool. Either way, I just don't know how to say if it's 3D. Like if it's 2D, I just save it as an image. But if it's 3D, there's no 3D images or common 3D volume format. So saving blue noise volumes, that's what I'm asking about right now. So like my best bet right now, I'm thinking, is just outputting fucking man, as soon as I go live, people start messaging me on Discord. It's like, god damn it, I was here. Anyways, it's fine. I'm not really doing anything this afternoon anyways. But anyways, if you have a 3D blue noise volume, you can't save it as an image, so my best idea right now is just outputting it as text. You can see my blue noise generator right here. See what it generates an image, just outputs an image. Also has the option doing a float array. But that gets huge fast, so I probably want to offer a binary option too. I may as well, like, my whole logic is if I'm making this generator, I may as well make it a one-stop shop for generation, have it all done in the format. You know, I just realized I didn't even switch the screen over to show. Let me make sure. Okay, I switched it over now. So you can see, here's the blue noise generator. Normally generates an image, but you can also generate as like text. So you could just like copy this into a C program, and you boom bada bing, you have a blue noise texture. Hey Shandu, it's going good. I'm just talking to some people about oh my god. Man, I gotta get used to this streaming thing. I keep forgetting to switch between my two scenes in OBS, but you know how it goes. So I'm working on my blue noise generator, but I'm talking to some people about how you use blue noise first because I haven't even used blue noise besides the 2D version. Wait, does this cut off my face? No, it doesn't. Okay. I can only see you, not your code. Don't worry, I'm not coding yet. I'm just talking to people on Discord. Here, I will show some code though about what I'm talking about. So this is a uniform sampling function. It converges over 5 frames or 500 frames. And to me it looks noticeably different and better than this random. They're pretty similar. How did you learn this stuff? I hung out on Shader Toy a lot. There's tons of great examples to learn from here. And then I just like reading other people's code. I want to learn math first. I like to just do stuff that's fun, like messing around on this. God damn it, I forgot to switch my scene again. Hmm. I should test this around. I should probably stop talking to these guys and just and just work on the blue noise now, but I want to get everything understood before I work on it. I'm trying to explain to this guy what I mean. See, I'm not that good at math as well. So when people ask me what I'm doing, I actually have to go and think, wait, what am I doing? Do you know any good blogs for learning math for computer graphics or building shaders? You know what? I do. The blog that I used for learning this blue noise, are you're in the Discord? You know what? Right? I'll just post it in the Twitch chat. So this is where I got this the same. This is the guy I'm actually talking to on Discord right now. Um, yeah, I used his algorithm to generate, not his algorithm. He wrote an article on the void and cluster algorithm, and oh, I forgot. Definitely not physical. The website has the best CSS. Yeah, it's a good site though. Check out the blog. It's actually a lot better. Screw it. I'm just gonna share this shader in a sec. Alright. Here, now people in chat can also see the same shader that I'm working on. Oh wait, I copied the wrong thing. Let me make sure that works. Yeah. So in buffer A, you can change the Are you learning by building this? What do you want to achieve by building this project? I built a real-time path tracer for Unity like 3 years ago. I just really like path tracers and realistic lighting. Ray marking, did you try that? Yeah, that is ray marking that I posted. That shader that I posted there is ray marking. Yeah, so what I'm testing, it's really hard to see, but basically there's different noise functions. So this is completely noisy, or actually that's uniform. You can see at the beginning it has kind of a pattern, but basically it samples fairly uniformly across space. This hash samples more randomly, and it's a bit more noisy as far as I'm aware. You can kind of see right there. I suck at doing OBS stuff. It is using more CPU than my GPU. Damn, well, it could be running non-hardware accelerated. I should set up a test example for this. Getting 190 FPS. That's crazy. Okay, 60 FPS. That would be, you got that on that shader, man, you got a good computer. Set up a test for this. I actually gotta turn off ShareX for this because I don't like the keybinds for ShareX. Oh wait, why did I close ShareX? I should have just turned off the keybinds. So right now I'm gonna compare in an image the hash and uniform sampling. I've done this with larger iterations, but I've never done this with lower iterations. So I know at higher iterations you can really notice the effect, but with this, I don't know. So basically what I'm doing here is I'm copying the random one, posting it beside this. Then we can compare the noise. It looks basically equal at these lower samples. Oh, you can't see it. I'm an idiot. All right. Top is the jittered grid sampling. Bottom is the noisy sampling. They're very much equal. This one might be a bit smoother. You look like right there. I think it's definitely a bit smoother. Looks like a random pixel generator. Yeah, it's not actually a very good random function though. Maybe it'll be more noticeable at like 10 paths. Wait, I actually think it is better. No, it's basically the same. You need dual monitor setup? Yeah, I do, but I don't have room for dual monitors on my desks. Why did I say desks? Desk. Anyways, why am I working on this? I should be working on the blue noise generator. I just love ray tracing, dude. It's like, do you know any noob math blogs for computer graphics? Not really any noob ones. Most of them can cover a lot of advanced stuff. All right. It's telling me to look at XOR shift, random generation. Also called shift register, our class of pseudo-random generators. Is that like FNV1? LSG generator. Linear congruential generator is an algorithm that yields a sequence of pseudo-randomized numbers calculated with this discontinuous piecewise linear equation. Method presents one of the best known pseudo-random number generators. Modulo arithmetic. It's basically based on, as far as I'm aware, the same thing. I think FNV1A is a Zorship generator. I don't know. Anyways, I know this is like exactly the same now at lower sample counts, but I'm going to test it again at higher samples. Just do 1,000 samples to check. So you can tell when this one's done too, because the lines and patterns disappear. Alright, so now we gotta do it with the noise function. So it took 13 seconds to render, so we'll wait for that. Alright, 13 seconds, there we go. I think it's actually noisier than this. I don't know, we'll see. I think the proper way to actually measure this would be doing a histogram. I swear there's a histogram somewhere here. Levels. Oh yeah, so here's a histogram. Alright. So if you select the noisy area here, wait, I think curves also does a histogram. Yeah, it does. So it's actually easier to see the histogram there. You can see the spiky noise. It's measured in the same spot right here. Yeah, so there's noticeably less noise, at least in a histogram. Let's try doing a copy. Oh yeah, so you can actually see. Let me mark that line. What does histogram do? It displays the strength of different image components, their intensities. So as I'm changing this code, it should update in the shader toy I posted. All right, I know what I need to do. First of all, I'm editing this just to show as an example. I saw your YouTube video, Math Canvas. Is it a graph visualizer or something? Yeah, it's exactly that. I actually use it all the time to test stuff. It's great. This last thing in here is I was testing an exponential power function and how it expanded at lengths above zero, and then I realized it only works with negatives. It's actually great for visualizing, and then you can save it as an image. I I honestly just like graph stuff all the time, and Wolfram Alpha was slowing. I was using Wolfram, and then it kept slowing down. So then I just decided I'll make my own image, rotate. Okay, there we go. White noise. other. So that is built in WebGL, I guess, since it is a canvas. It's Canvas 2D, not actually WebGL. They asked me on Discord to generate blue noise. Alright, so this is the comparison image. Canvas. Can you understand this stuff? Yeah, it gets the 2D context for drawing on the canvas. The link I pasted. No, it removes links, so I'll have to post it on Discord. Man, I have so many things to ask these people. God damn it. I should have joined this Discord sooner. This is like... I also have like 5 shaders running on my computer. Shader to our Discord channel? Yes. So I'm just thinking if I'm going to make this n-dimensional, how do I want to do this? Do I want to implement Michel's best candidate? I'm getting told now that capacity constrained Voronoi is better. Then there's also low discrepancy blue noise. Okay, so basically what I'm going to be doing is I'm going to be converting the blue noise texture generator into an n-dimensional generator that doesn't just generate images, it also generates volumes. And then I'm also going to be making a sample point generator that uses some different method, either Michel's best candidate, Poisson disk generator, which, yeah. Bloom noise takes minimal amount of blur to disappear, but you need something to compare it against. Alright, I can DFT it. We can do that. Alright, so what we're going to do, I accidentally switched the wrong scene for a second there, is we're going to take this Poisson disk sample and we're going to run it through analysis, frequency analysis, and see if it has blue noise properties. Alright, so I'm going to run this through frequency analysis. I've been meaning to make a shader for this for a while, so may as well do it now. Instead of doing discrete Fourier transform, we're going to do discrete cosine transform because it's a lot easier. So I already have discrete cosine transform here. And actually, one of the tests that I got told I could do is also try blurring this. I'll generate it closer together like this. Then I'll try blurring it. No, yeah, I think I'm going to need to do frequency analysis. Alright, it seems like I'm actually going to be using Mitchell's best candidate. So that's cool. Alright, so the discrete cosine transform code is right here. We just need the type 2. So what it's going to do is, first of all, it's going to need to read in itself buffer 0. Then I'm showing, nope. Okay, so we're writing some GLSL code now. We're going to do some frequency analysis with the discrete cosine transform. So the first thing we're going to do on frame 0 is we are going to do the x-axis of the forward cosine transform. We're just going to do this brute force, add up all the values. So for this, I believe we also need the texture size. Is there a way, OpenGL, GLSL, get texture size? I think there might be a way to get the texture size. Simple way to get texture dimensions in GLSL. Texture size. Ooh, nice. And it's there in 3.3. Hell yeah, that's what I'm using. Okay. So texture size. Actually, what does this return? Returns IVEC2. Alright. Do text size. Texture size of text. Oh, wait. I'm just going to be setting the screen to the texture size. I'm an idiot. So this is just going to be screen X. Like that. So then instead of UV, I have times 0.5 plus 0.5 times the screen screen size like that. All right. I also need the constant pi. All right, there we go. So that's the first frame. And actually, instead of I channel 0, this is going to be taking in text. Then this is going to output that value. And then on frame 1, it's going to do the Y version of that. So basically, this is doing Fourier discrete cosine transform across the horizontal rows. And then it's doing it across the Y columns. This way it'll do a full 2D cosine transform. And then after that, we are just going to return the buffer itself. Oh, and right here, it's actually going to take in the buffer 0. All right, so now that should be our discrete cosine transform. And then we also should be able to mask this to show a specific frequency. Okay, so first of all, we're going to set our shader to DCT. Buffer, undeclared identifier. Texel fetch, no matching overload function found. Oh, maybe there's no texel fetch in this. Cannot convert median p float to 4 vector. X plus equals. I don't know where it's assigning. Let me look at this. OpenGL 3.3 texel fetch. Maybe there is no. Oh no, it's just an OpenGL 3.3 ES. Oh, okay. Equivalent. OpenGL 3.2 texel fetch. Texel fetch version. No, it's in 3. So the coordinate must not be correct then. Alright, I should close these functions too. Hold a second, I'm going to check on Discord. Alright, so what am I doing that's not texel fetch right here? sampler 2D, text, ivec2, x, y, I divided by screen y. Oh, hey, it works. Alright, so now we gotta set the options. I believe we saved it as test samples. Alright, that's noisy as heck. I feel like it's doing something wrong. I guess I gotta scale this down. B divided by screen X, B divided by screen Y. Times 100. Oh, it's looking pretty new. Blue. Hell yeah, alright. I'm gonna take a picture of that. Oh wait, it's the wrong resolution. Test samples 286 by 283. Alright. Looking at this, everyone uses the discrete Fourier transform, so I'm going to use the discrete Fourier transform because I don't want to do things wrong. So we're going to take this discrete Fourier transform code. I'm going to use it for the discrete cosine transform, or instead of the cosine transform. Hey, said who? I'm just testing out my Poisson disk sampling. I'm running it through the discrete Fourier transform. Basically, I can't believe I haven't done this yet, but I'm setting up a shader for doing frequency analysis, running things through the Fourier transform. I just did it with the cosine transform, but ended up not looking as good. Sounds like hell, man. No. I mean, the good news is, wait, let me post something in Discord. So I was messing around with the uniform sampling, and also, why do you have so sleepy eyes? I got like 5 hours sleep last night, and I haven't had like a full night's sleep all week. Like, how bad are I know? Look at my fucking eyes, man. Look at them. It's like actually, this isn't even. Look at the bags, man. Look at it's uh, it's fucking hard out here. Anyways, I did a bunch of tests on the ray tracing, and if you see, I did a comparison between the blue noise I posted in the programming section of the Discord, the comparison between the white noise and uniform sampling, basically spinning the ray around. And spinning the ray around at 2,000 samples looks noticeably better than white noise, because white noise, I'm guessing, repeats a bunch of samples. Alright, so let's take this Fourier transform code. It's right here. This does things differently, though. I'm an idiot. Do you know what is the thing of people dividing by such thing called the PDF? Yeah, I actually don't know. Probably probability distribution function. I think so too. I think you're right there. Probably right. Kappa, sorry. I feel like I'm turning brightness up and down in this when I'm pressing these hotkeys. It's actually changing my screen brightness in Firefox. I don't know what's happening, but changing the scenes in OBS is changing the brightness in Firefox. Oof. So this is just the plain Fourier transform. I'm copying this code. I think using PDSF function helps with convergence. Yeah. But I don't know how to do probability distribution functions. I know how to sample an array of probabilities, and it's like super slow. You have to loop through each index of the array. So like, yeah, I don't know how to actually do something like that. The the BRDF for ray tracing, I think, could be considered a like a BRDF is literally a PDF if you think about it. Bidirectional wait, bidirectional ray distribution function. That's just like a probability distribution. It literally is a distribution. At least that's how I'm looking at it. All right, I got a question to ask the people on the Shader Toy Discord. I need to figure out how to display this stuff. Okay, anyways, so converting this to the Fourier transform is really simple. I think it's actually pi 2 if I'm right, instead of pi 1 like here. Pi 2, yeah, it is. That's interesting. So the cosine and sine transform of pi 1, so v plus equals texel fetch, complex multiply, so the first thing just samples the x of the texture dot xx like that. Then it gets the angle with x times 2 times pi. There we go. Also, there's a thing where you have to divide by 4 times pi. Oh. I just divide by the screen height there. But yeah, this display part right here where I convert from the complex number to some grayscale value to display, this is what I don't know. So something where you, oh, I mean in path tracing. Wait, actually, one sec. Let me, here, I'll post the path tracer I was sharing there before. Alright, just posted in Discord along with the image. If you look in buffer A around like line 50, the BRDF, right here, this is the main BRDF. As far as I'm aware, it's pretty realistic. It takes in this random x and y, which is this is the other sampling I talked about, the uniform fract sampling. So how random x and y go into the BRDF is the random x is run through a curve for the roughness, and then it's converted to polar coordinates through sine, cos, and phi. Is that how you pronounce it? How do you pronounce PHI? I wonder if Google gets this.
Phi.
Phi. Whatever. I feel like that's wrong, but we'll do it anyways. Converts it to polar coordinates. Then it converts to Cartesian from those with the using the tangent and binormal. So like to sum it all up, this random x is the amount of randomness along the, like, if the normal is straight up, the roughness is the amount of like sideways angles it's going to go. If you look at the way this actually works though, is you've got the random x right here, then the random y is constant right here, but because of the way it works, it's so complicated, but like, so the z, all right, oh man, I can't even explain this, but like basically it simulates a surface of random roughness. So you could customize this to make roughnesses that are like more on the x-axis than the y. Like for example, some metals will like make stuff. Anyways, this this is the uniform sampling function I've been testing. You can see while it's sampling, it has these weird patterns. Well, not weird patterns, the noticeable patterns of where it's sampling. But after the 1,000 or so frames that it samples, it gets perfect. And I've noticed it's a lot less noisy than just using white noise like this. But I'm still trying to find better ways. All right, what are you working on? Said who? I got to get back to working on this Fourier transform. To play Gothic again, I fixed my computer. So was it your RAM sticks? I don't know. Now when I moved, it's fine. Oh god. Well, there's cosmic rays as well. Alright, let's view this. Shader 0, dft.glsl. Error, cannot convert. Oh, this is supposed to be XY and buffer 0 too. I'm still trying to think what I should do with my shader still. Yeah, because you're stuck on the pathfinding, right? Oh, this is vec4 instead of vec2. Arrow Y undeclared identifier 37. Oh, this is supposed to be Y. Oh wait, I have these backwards. I gotta floor this UV as well. I looked more into D star. It looks quite efficient. D star light. Oh. Watch this 1 hour thing about AN pathfinding. Well, if there's one thing you're gonna watch an hour on, pathfinding, almost definitely gonna be a good use of your time. Like, I'm not even joking there. Like, everything self-driving cars, it's all gonna be around pathfinding. I think that would be assuming it's a good talk or hour thing. I would look at watching that. Awesome, here we go. It's just way too dark. So we're going to do log negative, log negative times 0.1. Yes, I will post it. All right, I'll look at it. That is not displaying anything. Oh no. Oh no, something's wrong. It's an MIT course. Oh, nice. Open courseware. I've heard MIT's courses are pretty good. I feel like this is supposed to be divide by res. No, that's all the same. Plus equal pi times 2. Yeah, I watched one on QM, was quite confused. Yeah, I bet. We don't even understand quantum mechanics yet, so, well, we don't understand all of it. So I'm just looking here where I divide by the resolution. I'm not doing that right there. That explains it. I heard the Jizixta didn't like go to, oh, like the the writer of the algorithm. Jizixtra. I don't know how to say that. Go-tos are amazing. I think, yeah, I don't know why people don't like them. There's like some cases where you literally need go-tos. Like it'll actually make your code way less efficient to not use a go-to. For x times 2 pi divided by screen x. Yeah, this all looks good. Maybe it's just not loading my image or something. I don't know. Oh, let's replace buff 0 with text to see. Oh yeah, it's still there. Oh wait, that's actually the wrong sample pattern. I wanted to do a more dense one. Alright, I should find out what's wrong here though. X multiply, xy here. Oh, this is xx. It's supposed to be x0. Alright, something's messed up. I'm doing something wrong somewhere. I gotta close these extra shaders though. It is harsh on my computer to leave like 3 shaders open. So what did I do here? 1 plus log. That didn't look bad. Alright, complex multiply. I feel like times screen might be like this. Nope, that didn't change anything. Oh, what the heck? Oh, that did change something. It broke it. It made it get gradually smaller. Wait, is -1 the forward Fourier transform? Did I just confuse that? No, that's not it either. Ah. Let me look at this. Direction equals state divided by 2. Direction 0 is the forward Fourier transform, which is -1. Oh, did you post? You posted in Discord? Incremental path planning. I sent you good code. And this compiles. I don't use Godbolt, so where's the compile button? Preprocessor output. Am I blind or like? Output. Compiler returns 0. -E. What were you doing there though? Was there like some goal there or something? Or are you just messing around with the compiler? Custom while loop. So you're just messing around with the compiler. You're trying to make your own compiler in the compiler. Yes. Yes. Find equal resolution. Have I shown you my math library? Did you end up finishing that vector math library? I'm gonna go play some games after this. I'm just dead today. True. Is it a different math library you're talking about? Or is it that? Uses macros to do constructors. It's efficient then. I wish I would do more work on it. Just breaks my head every time I do. True. That happens to me a bunch. Like right now. I'm not doing x times or y times here. I'm an idiot. I'm an idiot. I've as well even thought of a way to do GLSL style swizzling. Oh yeah, with macros? Why the hell did I just refresh that? Yes, we got it. And it looks pretty blue. Alright. So now we need to display it in an effective way. So we're going to do a pass where we convert it so that the higher frequencies are all close together in the middle. The higher frequencies are all out at the sides. So to do that, we need to apply some sort of distortion here. Also applying a scale right here. Alright, so what I have to do here is do like why I already have the code here in that space. Shader toy frequency. Okay, I don't know why it's not bringing up the shader, but I'll go and find it here. So like would have empty structs that I use as identifiers in the union of the vector when I pass this member to a mac. Oh, yeah, you can do it with unions as well. It's a good point. See, what I actually do is I don't really do swizzles. Oh wait, yeah. So you actually can't do that with unions. I'm thinking about different. You can do it with a mix of unions. Alright, so what do I do here? Mod plus res by mod. That's easy. Okay, so mod screen plus screen times 0.5. The real GLM does it that way, will accept C++ template magic. Ooh. It works, the frequency's in the middle. But the values are too low. Maybe I should just use length. Alright, that's pretty blue. Have you seen that source code? It's pretty insane. No, I have not. Alright, I'm going to post this on Discord. It's pretty insane. Are you posting it in Discord? I'm here right now. Damn it, I output the image alpha, so it displayed wrong on Discord. I gotta go into the curves and edit it here. So this is the frequency spectrum result. You can see the one low frequency in the middle. See, it's lacking a lot of low frequency. Does anyone in the shader toy server know about pathfinding? I don't know, you should go and ask. They're pretty damn smart. But you never know till you ask. Insanity. Swizzle.hpp. Internal class for implementing the swizzle operators. Oh my god. It's still powered by macros though. Actually, no, I think those are type defines. Maybe. This doesn't look very efficient. I wonder how much the compiler of this actually optimizes out. A macro called function. A macro called function. That's fucking good. No, it's just the macro name. Dude, this code. Okay, I feel bad about some of my code being confusing. Not anymore. Not anymore. Thanks for posting that though. That's good. I had to read it to get ideas for my own lib. Mine's glmc. True. Nice. Yours has matrices and everything as well, right? Oh, nice. A hornet just hanging out in my window. Wonderful. I just completely fractured a sentence. I did it first, but I had to remove matrices because the general idea was not working. It's much harder than C++. Dude, matrices are fucking hard. Alright, so it seems like these sample points are pretty good. We're going to look at implementing Mitchell's best candidate now. Or should I look at doing the n-dimensional of my blue noise generator? Or not my blue noise, Ulichinese. Should probably do the n-dimensional version first before doing something else. I'm happy to have this DFT code done though. Now I can just analyze whatever, whenever. Did you post the code in Discord? There we go, type vec2. Vec declare. See, I can already understand this a lot more than the other. It's old, like way old, doing structures. Not bad though. I just type out all of my functions in the vector math. In my vector math header, I just typed out all the functions. I don't even use macros or anything. It's fine too, yeah. It's fine, but it's like what people prefer. Alright, so I think I am gonna look at making this blue noise generator n-dimensional. I just may as well just go for it. I found a way of doing it now which is much better. Like it uses variadic functions and macro is just a shell for it kinda. Oh yeah, variadic functions are probably better. Alright, so I need to add an option for this to do volumes. Like otherwise you have to do logic using generic, which is terrible. Ah, yeah. So I'm gonna add an option that's like higher dimension or something. I'm also going to rename type down here to format. n-dimensional double array. That makes it way bigger. N dimension. So then count is going to be the number of dimensions. All right, so this is going to be the difficult part. Turning work into work n that's n dimensional. So I'm going to get some water too, but one thing I just remembered is I think the guy has, the Alan has the link to the paper here. Where is it? I'm looking for the actual Lichny paper. Here we go, 1993 Lichny paper. Void and cluster method. Like to include that in the source. Rip, I think I'm gonna go play some Dirt Rally. Have fun. Alright, so the actual code is in here. So thanks to DemoFox, write an article, put that in both. So work will be 2D. Alright, I'm gonna go get some water. I'll be right back. Actually, hold on. I'm just gonna check Discord. Alright, so I just got another message back, and apparently, or what I figured out is this could be the way I'm rendering the dots. So instead what I'm going to do is I'm going to make the dot rendering a lot sharper. Doing like ×5 right here. ×2. I don't know how actually I would do this. If maybe if I do -0.2, -0.5, -0.4. If I make the dots on and off, so I need a way of rendering the points on/off. So instead of sampling nearby points, what if I just change this I just change this to output true if there's a point here. So I channel 0 to U0, vec4 step dot x vec2 1, and a step of -1e -4, or some small negative number. Awesome. Now I can put them closer together. Now let's try taking a measurement of the frequencies of this again. Bounding rectangle of that. Then I'm going to cut off 1 pixel, 134, and then we're going to save that as our test samples. So now we're going to open this up. Our testing. We need to set the width and height correct. Did I set them wrong? 34 by 134. No, it's right. I guess I just got to change the scale of everything. Oh, that looks a lot better. Oh, and you know what I should do here so I can just take pictures of it? Just do, instead of doing vec4 like this, do it like this, and then I do xxxy. This way I can just capture it. Alright, I changed the points to render as binary, and it actually did work and reduce the ringing. Well, it seems like the noise generation is good to me. So we did the discrete Fourier transform of the poison disk samples, and you can see that it is lacking in the higher frequencies, just like it should for the blue noise. So that's awesome. means we're basically ready to go. Alright, so basically I'm going to be converting the void and cluster blue noise generation algorithm to 3D, 4D, and n dimensions today. It should be pretty simple of just looping through the points. So it should get bigger and bigger, but we'll see. The other thing that's going to be difficult is actually testing three-dimensional blue noise. So that'll be interesting. Anyways, I'm going to go get some water. Then I'll be right back. Here, look at some code while I go away. All right, awesome. It also feels really good to know that my algorithm's actually generating decent noise. So let's put on some music. Don't need shader view anymore. So we're going to be converting this 2D void and cluster to n-dimensional here. It'll be a lot slower, but I mean sometimes you need n-dimensional, so we're going to do what we got to do. Alright, let's go. So to test 3D blue noise, testing 3D blue noise, how would we do that? I mean, we can always look at a... See, the issue is you can't look at a volume like you can look at a two-dimensional image. When you look at a two-dimensional image, you can see with your eyes. With the volume, you just kind of have to expect that it's actually working. Anyways, let's just do it. So first things first, we're going to add an extra variable called dimensions, or dim. So I guess I'll start with these functions. So it takes an index and it has to convert. There's going to be a bunch of cases here where I'm going to have to convert index to coordinate, it is more efficient to put it in here too. This is going to be a lot less efficient because I'm going to need to store the points in arrays. So the thing is, though, with JavaScript, what the hell is it doing? YouTube. So I should be able to create a more efficient way of doing this. To store a 2D point, so use a float 32 array or int 32 array. I guess I'll just use array. So point of dimensional size, 1D index to n-dimensional point. This is fucking epic. Probably partly because I have it blasting. Alright, so we need to split our index. So the last value will actually be generated first. So what do I do here? So it starts with math.floor. Actually, I could generate the index to point function. Wait. JavaScript web worker eval. Create a web worker from a string. So I actually think this will be more efficient if I create a function that generates the function. Yeah, whatever. For index divided by size. I guess I can do this without floor just by doing mod, but I should really pre-compute this. So if it's z here, it'll be size divided by size, I believe. Point I, set I to 0 again. So point I equals math.floorTemp. How can I make this an iterative function? T D1 is floor temp. I equals D1, I minus minus. Ti equals This is a really bad way of doing this. So first of all, this stores different divisions of the index. Then point I equals index minus point I floor. And then index is the last point. You know what? I gotta test this function in normal JavaScript before I test it here, because I'm not even sure it's gonna work. We'll see. I minus 1 minus point I. This is actually I minus plus 1. Okay, let's test that out. Index to point. D1 is not defined. Not a number, not a good start. Okay. Oh, size is also not a number. Ah, so I forgot to do mod though. So what I have to do is mod size. Awesome. So that gives us our 3D point. Ah, is that wrong actually? The last one I think is wrong. Math.floor index divided by size. Oh no, it's just point I. Oh, so there's something wrong there. I should check this as 2 by 2. That'll actually be the easiest. So 1, it should go up to Y. It should go down to 0 there, which it isn't. Why does that stay as 1? Oh, because this is floored. Wait, so this should actually go... There we go, now that works. Ah, that's broken though. That should be going up on the Y. Now that's at 2. Math.floor. times size. Then that goes X on. Then it goes Y on. Awesome. Alright, so our index to point does work. Alright, so I'm going to copy this index to point function. So now right here, when you get the index, you're going to have point, index to point, index. And then right here, we're actually going to need to loop through the number. So the actual better way, I think, to do this would actually be doing metaprogramming, where instead of doing a bunch of loops, you actually use eval to generate the code. I don't know, let me write this out as a loop, and let me see. This would be for d equals d bigger than dimensions. Yeah, so doing this with metaprogramming would be so much easier. That's probably what I'm going to look at doing. Because without doing this, you would need to write like you'd have to write like a custom increment loop, or you would have to run this each iteration. That would be a lot slower. Yeah, I think I'm going to look at doing metaprogramming for all this. Okay, so I'm going to try and generate index to point. So metaprogramming is basically where you generate code with code. So that's what I'm going to be trying to generate. Set up my test dimensions of 3 and size 2. Okay, so function or index to point equals eval TS is going to be our test string. It's going to evaluate the test string. Okay, so function. Can you write multiple line strings in JavaScript? I think you can. We'll test it out. Nope, after escape line break. So I think you have to do it like this. We'll see. There has to be a way to do multi-line strings in JavaScript. I guess it's just plus. Alright, so we're going to generate the code for our function in a string. So our function is going to take in the index. So the other thing is, I should already have a temporary value ready to reduce allocations to output the point to. This is epic. What soundtrack is this? Witcher. It's freaking awesome. Okay, so for var dimensions. So we're going to inline all this stuff from before. Point equals index, this equals index divide equals size. I think I also have to do math.floor between each of these. Not sure though. I don't think so, actually. Then after that, we do this part. Math.floor. Point I minus point I plus 1. Oh, math.floor times size. Modulo size. Alright, and then finally we do plus dim minus 1. It's math.floor. Dim minus 1. Okay, let's see if that compiles. Syntax error, string literal. Forgot to open or close one of our strings somewhere. Got the plus. Index to, okay, so now we need to generate our point. Awesome, it works. So this gives us an efficient way of doing multiple dimensions, so we can actually compile the functions for whatever dimension it's running in, which is actually a pretty cool thing about JavaScript. I mean, I bash on JavaScript a lot, but this might actually be one case where it's actually useful. Oh man, there's some cool math discussion going on right now in Discord. Alright, let's continue. So now that we know that this works, we can basically use this for all of our code here. So we'll comment out this old code. Functions that are I guess let's generate the functions here. So I should probably change how this loads first of all. So if the last type is the double array, which is 6, so if type bigger than 6, work n.js. Just include the count, just to be sure. Alright, so now the dimensions will be the count. Dimensions is mentioned message data 4. Alright, so I should paste this code. And okay, our first part. Total size. So this picks random points out of a hat. So I'm going to need to do this loop in n dimensions, I think. Oh, actually, no, I don't. I can just do it in total size. I bigger than total size, I plus plus. Compute energy. So this is one where I'm probably going to need to generate the function. Compute energy values custom. Alright, compute energy values. This is going to be the hard part. Let's go. Var comp energy equals eval. Maybe I should make a template for doing this. Alright, so this is going to be a number of for loops. For var en equals I plus I vn equals 0, vn bigger than size, vn plus plus. Oh wait, I can make size constant for this too. vn plus plus. Awesome. That does the beginning of two or however many dimension for loops there is for the dimension. And this just is going to be the repeating end like that, repeating end parentheses. I'm actually not going to need this that much. I should have created this as a custom function. comment this as well. Oh, excuse me. Handles negative boundary without discontinuity. Alright, so generate a flesh 38. I'm making a blue noise generator right now. But I'm making it for n dimensions, so I need to do some special kind of programming to make it support more than 2D. Like right now I'm using eval to generate functions for the specific dimension size. What's blue noise? It's high frequency noise that's really good for dithering and ray tracing. So you can see here I'm creating code that writes code. That's what I mean by I have to write damn, this requires a lot of concentration. Also, I shouldn't put spaces where I don't need it, because it'll make it compile quicker. Gotta think about this differently than normal programming. I'm not trying to make it beautiful, I'm trying to make it work quick. Okay, cool. Did OBS just freeze? No. Oh, actually. No, it seems like it's good. Alright, so we need to convert this 2D compute energy function that contains two for loops. So CSE is going to be our function string. Do it like this. It's just going to operate in here, so it's not going to have any variables passed in. So I guess the first part is the loop. And then it's going to have the for loop, so the dimensional for loop. I'm going to call this L, or I guess I'll call it I. And then it has the EV and OB counters. So far, EV equals 0, OB equals 0. Then it has another for loop, which we'll call J. What do you need to generate code exactly? Well, this uses JavaScript, so I just have eval, which is a function that just compiles JavaScript code in JavaScript. And I need to generate it because, for example, you can see, or it's most efficient to generate it because if you see this 2D function, it has two for loops. to create this without this metaprogramming, I would need to have one big loop that then has code that converts from the one big loop to these. And it basically does a whole bunch more instructions if you don't write the... it's basically a lot less efficient if you don't write the code specifically for the dimensions. Alright, so now we've got the code inside the loop right here. This is going to be the actual hard part. We've got the value is the binary OB++. Then we've got if that value is 0, continue. Okay, so now we've got to calculate the difference for each dimension. See, so n dimensions equals n nested loops. Yep. Also, I just realized I calculate these as separate variables, but I can actually sum them up. So SD is going to be sum distance. So then while this loops through, it's going to go distance. Actually, it'll declare it here. X. Okay, so I am going to need to access these array values from before. So this is the other complicated part, is I'm generating the for loops up here, and this will be like I0, I plus I, and J plus I. Like, oh, it gets so confusing. Let's just get it done. So X, this first part here, X equals the first X minus the second X. So I believe that's I plus I minus J is I. Equals that. Oh yeah, and then there's the absolute X. So I'm going to do A equals math.absx. And then I need to do this, which is the wrapping distance. So I need to go if A bigger than size 2. Oh, and I'm putting these spaces between stuff when if this is compiling with eval, I want as little characters as possible so it compiles as quick as possible. A bigger than size 2. What do I use size 2 for? I actually think this could be sped up by doing a for loop. Or, sorry, floor. What am I saying? Okay. So bigger than size 2. Then what do? Then we do, then the X equals the size minus the absolute distance. So you're using both I and J both in your program and your meta program. Perfect way to melt some braids. Yes! Save characters, melt braids. Size minus A. Alright, sweet. So now that calculates... Oh, actually, the last part of this is then SD sum distance plus equals x times x. And then at the end of this, I do the EV plus equals math.exponent sum distance times sigma Alright, and now I need to close one of these for loops. So that's just plus equals closing parentheses. And then I need to output to energy here, so I do energy E plus plus equals EV, and then I close the rest of the for loops. Okay, so we have generated our first n-dimensional function here. Oh boy. That's this is gonna make the code so much larger. This is gonna be like a whole project looking at this. Oh my god. So eval. So then I would just do eval like this and call it. And that should generate it. And I just call the function from eval. Man, this code's so weird. So I wonder, does this... Okay, no, so I don't have to rewrite this. I hope it's not meant to take any kind of user input. No, so this is what it is. Blue noise image generator. Right now there's the grayscale like this, but I want to do this n-dimensional. The n-dimensional is the code we're writing right now. So I already have this app working. I'm just extending it to higher dimensions than 2D. And actually looking at this, like this is going to require a good amount of testing. I might actually work on this more tonight. So we have to write these add and remove energy functions in the code now. So we need to do more meta programming. I deleted some code here too that I shouldn't have. Alright. Generate, add / remove energy functions for dimension. So this is our add energy, 2D add energy function that I'm going to be basing this on. So I'm going to comment this out. Use this as the base. Also, hold on. The sun is shining right in here. You can probably see my face getting brighter. It's like shining right on me now. I gotta close the blinds or it's gonna get really hot. Alright, I didn't close them completely because I still need some light, but now the sun's not shining on me, which is nice. Alright, so add energy, ADE. Start off with our normal function. This has the same var b as index. And it starts off with the same type of for loop. So we can just do plus equals dim for I. Then it does actually very close to the same code here. Wait, this has the same code as here. I've got all the blind closed and the AC running full blast. Yeah, this was the first cool day we've had in a while. We actually turned off the air conditioning. We have been running our air conditioner like basically this whole month. So what I'm thinking I can do is I can just actually copy this code up here or save it to a string and then do basically the same thing down here. I just have to replace this with a minus at one point, and then I have to replace this IX with like the I0. I guess I can just copy it. Or do it a different way. So ADB for the buffer, because I'm basically going to use all this same code for the generating energy. Oh yeah, so I forgot even this first part. I need a point buffer. So this point, I think I'm just going to allocate it right here. Just an array of a number of dimensions. Might actually be an int32 array. I don't know, it doesn't really matter, I don't think. That would make it faster though. So this is the part 2 where I need this index to point function that I already programmed. I'm just renaming the variable because it's in a different context now. And let me see. Yeah, I hard-coded size here. Or I wrote size out there, but I should actually do it like this to be more efficient. Alright, sick. Index to point equals eval IDP. Alright, so we're going to use that here. The first thing we're actually going to call before this is index to point. Oh yeah, I forgot. So add energy here is going to take in an index. That's going to call index to point on that index. And then instead of this for loop, what it's actually going to start doing is it's going to store the dimension vars outside of the array. So what this is going to do is make it a lot more efficient accessing it. So what should I call them? Dimensions. I'll call it X, or actually K. Plus I equals I does not equal I equals 0, then nothing. Otherwise put a comma before. This equals what's it called? Point plus I without a semicolon, I think. And then I put a semicolon at the end. And then I do this for loop. Okay. So then I have to do the same code as up here for computing energy, which I think I should just copy. So in this I call it I and J. So actually if I put this in a buffer and copy it over, so I do var temp equals so now the only thing I need to change is the minus equal here. So then I should name these I instead, and then name this J. Then I can just add this CST part. Awesome. So then it's just A to E plus equals A to B plus EV plus the math function here. And then closing all of the for loops. So wait, the subtract energy function is the same as this beginning one too. Looking at it. The only difference is minus equal here. And then I think the last part is just this end of the function, because it doesn't return anything. Awesome. So now add energy equals eval ADE, sub energy equals eval SDE. Alright, sweet. I actually think that's everything. in index, remove energy, add energy at the index. Oh, I had an error here. I'm just looking over the code and I'm making sure it's exactly the same. Yeah, none of this stuff references the dimension, so it should be the same. Yeah, all this stuff is non-dimensional, so it's just this last part where it computes the zero energy, and that'll basically be the exact same thing as this compute energy. Just instead of equals 0 here, it's equals 1. So how do I do that? Compute 0 energy. I guess I could just do CSE.replace TV equals 0 with equals 1. And then down here, then I can just call CZE or eval CZE. And then once again, none of this is dimensional. So all of this is exactly the same to begin. So technically speaking, oops, I should just be able to replace work with workend.js here. It'll probably have an error, but we'll see if it'll generate. Syntax error, unexpected token. And it gives me no reference point of where the unexpected token is. That is exactly what I was expecting with metaprogramming. Alright. This will be fun. So the go-to method right now for me for debugging I guess it's just going to be reading through all of this. There's an unexpected parentheses though, so if I had to guess, it's me typing parentheses, you should generate a debugger. I wish I could do that. I think actually, wait, can I output to the console from here? Oh, okay, I can. So what I'm going to do is I'm going to output to the console the code I'm generating. So that way I can see if there's any issues with the code. So we're going to do this one at a time. Alright. II, JI, I0. Yeah, so that isn't working. That's that looks correct though. Wait, so when it's doing the for loop here, why is it doing I? Oh, I'm an idiot. I'm adding the number variable I. Function b equals 0, for I is equals 0, I 0 plus plus, j 0 greater than 8. X equals I0 minus J0, A equals mathapps X, D plus equals. This is all looking like it's good, so it's probably not here. This is compiling correct. We also know if it doesn't run the code, if it doesn't print out to the console, then there's an error before the console.log because it stops execution. Point index. ADE. It's not here either. I think it might be down here. The SZE or CZE. Oh no. It's actually right up here. It's one of these. It's either the add energy or sub energy. Alright, it's add energy. And sub energy. Yeah, so it doesn't output work. Okay, so our bug is somewhere here. Function index to point. I think that might be the bug. That's supposed to be index to point var remove energy is not defined. Oh, so it compiled now. Sweet. Got to go. See ya. See you around, Flesh. Hope you have a good day. Remove energy is not defined. Sub energy. Oh. I didn't name it the right thing. Index is not defined. Index is not defined. I like how this actually doesn't take me to the code. Thanks for following, Flesh. Okay. So I don't think it's IND right here. I don't know though. Let's look at the pile of code. Index is not defined. Line 139. Add energy equals function index. Index the point, var I 0. Index is undefined. So now I gotta see where this exception's happening. I'm gonna test this. This is the first real loop where stuff happens. Damn, undefined. Oh no. So I wonder if it's really computing the energy. I guess I can output energy right here. Float array 0. Yeah, it's not generating the energy. If I pass in energy, oh, I wonder if it can't access bin the binary data either. Nope, it's still not generating. I wonder what it's doing. I'm just talking on Discord to people. Man, the lighting gets really bright here. What the heck? Alright, I gotta focus on this code. So passing in the binary and that doesn't cause any outputs. JavaScript web worker eval. JavaScript eval versus new function. Web worker eval. Create a blob object that contains the source code for the worker, convert it to a data file. Oh, am I going to need to generate the code outside? I should check if eval even works. Does this even work? Oh, it does work. Okay. So I gotta figure out why this is not outputting energy. Let me try outputting the binary. What does it set the binary to? Oh my god. I'm an idiot. It was just setting the density to 0. So I figured out something that I actually need to check here. Figured out something that I didn't realize before. That if endpoints equals 0, so I should stop this before it even runs the worker. If size times density is smaller than 1, I guess I could just set the density to the minimum. max density. Alright, then size should also be maximum of 4. I don't know, we'll try 2. We'll see. Density is going to be the really hard value, so the minimum value is going to be 1 divided by size times size, or however many dimensions there are. So I guess I'll parse density last. If type equals... You know what? I'm going to do this all another time. I'm really dang hungry. It's getting to the end of the day. I think I'm going to continue this tonight as well, since I'm actually making really good progress with it. And I'm really excited that the eval code is running well and everything. So, this is going to be the end of this afternoon's stream. Thanks to anyone who watched. I'll be continuing to talk about this stuff in Discord if you want to join the Discord. Have an active programming section. Otherwise, I'll see you guys tonight or tomorrow or whenever I stream next. Probably tonight, in like 2 or 3 hours. We'll see. Other than that, I hope everyone has a good day. I'll see everyone later. Bye-bye. Thanks for watching.